In the last class, we were going through the uh, the application of object-oriented concepts. So we saw how to define a class and how to create an object. Yes. So a Java object, a Java class, I mean to say. So why do we create an object? Yes. So why do we create an object? Why did we do that? In the last class, we have created an object, right? So why did we do that? So basically, an object, a Java object, it represents a real world object, as I told you people, and it holds the details of a real world object, right? It represents a real world object, and the data related to the real world object will store it in this Java object. Yes. And what is a class? How do we relate a class to the object? How is class related to the object? How do we relate a class to the object?
You create an object from the class.
So we create an object from the class. Okay. So basically I can say that a class is a template for creating objects, right? Yes. So class is a blueprint or a design. A class basically it describes a group of similar objects. Yes. Okay. Yes. And what is a constructor? So we have discussed about constructor, right? Yeah. So what is a constructor?
It is a method
Okay, it's a special method.
of that method
Yeah. Why it is used?
to initialize the object. Invoke an object.
Uh, to initialize an object, I can say yes. So basically, constructor is used to initialize an object. Yes. So initialization means assigning some initial values to the instance variables which are part of the object. What are instance variables? Yes.
Property of an object.
Yes. Basically, you'll find that the instance variables they represent the properties of an object. Instance variables they represent the properties of an object. Yes. So they are also known as fields. So we declare them in the class. So these are all the things which we did so far. You see. So we have defined a class. We have declared variables. So these variables they represent the properties of an object. This variables, instance variables, they hold that property values. Yes. And we got constructors, a default constructor and a parameterized constructor. And one important thing, as I told you people, like, if we don't define a constructor in the class, then what happens? Usually, if you don't define a constructor in the class, then what happens?
The compiler will generate automatically one
Yeah.
for us.
Yes. So the compiler, what it does, so during the compilation, the compiler will check whether there is any constructor defined in the class. If not, so it defines it adds a constructor, I can say. You know what? And most importantly here, you'll find that it only adds a default constructor. It can only add a default constructor, I can say. The compiler, what it does, it only adds default constructor. Yes. Okay. So now we'll discuss more about this variables or properties here of an object. So this properties which you got here, this variables, I'm sorry, we call them as instance variables, I told you people. And there is something special about this instance variables. What is it? So each time we create an object, the memory for this variables is allocated. The memory for this variables is allocated. Yes. So that means uh, each and every object will have a copy of this variable. Every object will have its own copy of this variables, I can say. Yes, every object will have a copy of its own copy of this variables. Yes. So if I create 100 objects, then there will be 100 copies of this variables instance variables. Every object has got its own copy. Why do we need a separate copy of this variables for each object? As we have discussed, each Java object, it represents a real world object, and that real world object data will be different from another object. So especially these variables, they represent the properties of an object whose values, the property values will change from object to object here. Yes, fine. So, but you know what? Here, you will find that there can be properties in the object whose values will not change from object to object. There can be properties in the object whose values will not change from object to object. You know that? Yes. So there can be properties in the object, or there can be properties in the object whose values will not change from object to object. So can you people give me some examples for that, especially in the savings account? Can you identify any such property whose value will not change from object to object?
It is pin number.
Pin number will change, right? Account number will change. I'm talking about the properties of an object which will not change from object to object. If you consider savings account object, the property, account number, balance, pin, all the all these values will change. All these property values will change from object to object, right? Mm, Not even data types. Minimum balance, okay, again, maybe interest rate, that's right, Rupa. Yeah, minimum balance and yeah, and what else? That interest rate, name of the account holder. You see, account holder will change again. Yes, you have to understand that. Will all the account, like all the accounts of a bank, do they belong to the same account holder? Will not change. The account holder will not change from object to account object. Definitely, account holder will change from account object to account object, right? Yes. So I can take interest rate here. Okay. Let's say float. interest rate. Let's say this is savings account, right? Bank offers a standard interest rate. Let's say this is the interest rate which bank offers 4.25. Let's say. Okay. So this is a property of the savings account object whose value will not change from object to object here. Now you see this type of variable, um, sorry, this type of property account, you see, especially interest rate. So what if we declare it as instance variable here? It is an instance variable now. You know what? This is an instance variable. Yeah. So will there be an issue if I declare this variable as an instance variable? Is it appropriate to declare this variable as an instance variable? What do you people think? I can say no. Yes. No. Okay, just I'm sorry. Give me one. I'm sorry. Just a minute, please. Just a minute. Yeah, sorry. So, okay. So there is a question, I guess. Are we getting into getters and setters? Uh, uh, is there any special requirement for you, Neil, regarding getters and setters?
Not really. I was just sort of curious. I don't know.
Uh, no, this is not the right time to talk about setters and getters, okay? Yes.
Okay, just curious.
Yeah. So you can just bank on me. So at appropriate time, we'll discuss about it. Fine. So, so here I can say that, you know what, this property, interest rate uh, of an object, it's not appropriate to declare it as an instance variable. Why it is not appropriate to declare it as an instance variable here? Because, you know, that property value it won't change from object to object. That property value will not change from object to object here. Yes, you got it. You will find that always it is constant. So if you declare it as instance variable, what happens? If you create 100 objects, for suppose, if you create 100 objects, then you'll have 100 copies of this instance variable, right? Which variable interest rate. And in all the 100 copies, you'll end up having the same value. So do you need so many copies to store the same value? What do you people think? Do you need so many copies to store that value? Yes, not needed, right? You got the point, all of you. So if you declare it as an instance variable, especially this interest rate, now this property value is not going to change from object to object. It is going to be the same always, right? Yes. So that means it is not, it is just wastage of memory in this case. It's just wastage of memory, I can say. Yes. Okay. Then what to do here? You declare it as static variable. You declare it as static variable here. Okay. Yes. What happens if I declare it as static variable? You know what? If we declare this variable as a static variable, that means you'll find that you'll only have one copy of this variable no matter how many objects you create. No matter how many objects you create, you'll find that there will be only one copy of this variable here. Yes, there will be just one copy of this variable. So all the objects, which belong to this class, they will share the same copy of that variable. All the objects here, they share the same copy of that variable here. Yes. Yes. So that is about static. Whereas non-static variables, you see on top you have this non-static variables. So every time you create an object, you'll find that a copy of a memory will be allocated for this non-static variables as part of that object. But for static variables, that won't happen. There'll be just a single copy. So you people got it? Can I have yes or no?
Yes.
Okay, good. So how do we access instance variables using object reference, right? How about static variables then? How can we access static variables? So if you want to access static variables, then you need to use
Uh,
the class name.
class.
Yes, use the class name. So you see savings account dot interest rate. That's it. Use the class name here. Okay. So now, can you people give me any other examples here of static variables? Let's say you can consider any object you wish and tell me identify the properties which are static and non-static. Can you people do that? Okay. Uh, One thing what you need to understand here is I'm talking about the memory, not a fixed value. Okay, first of all, the memory allocation is important for us, all right? So now the way the memory is allocated for a variable, it depends upon the type of variable, especially whether it is non-static or static variable. Based on that, the memory allocation will depend. Based on that, the memory allocation is going to depend. You got the point? So if you declare it as non-static, each time you create an object, memory for that non-static variable will be allocated. If you declare it as static, then what happens? For each object, each time an object is created, the memory for static variable will not be allocated. That is the main difference. You got it?
Excuse me, Mahesh.
Yes.
I just got a question in regarding to the memory allocation you're saying. What is in real world scenario? What do you mean by memory allocation? Is it kind of a hard disk space allocation or RAM or what do you mean by that?
You see, we never talk about hard disk here. So applications always they use primary memory, which is RAM. Just keep that in mind. Any programming language, any application, they don't use hard disk, secondary memory. So an application basically primarily uses primary memory itself, that is RAM. Okay, fine. So now you see, uh, most of the people here they got one more confusion regarding the static variables. So what is it? Now let me see how many of you people uh, will answer this question. The static variable value, can we reassign it or can we modify that static variable value? Is it possible?
Yes, we can modify the static variable value.
Okay, so we can modify. Yes, that's right. You know what? We can modify the static variable value. Yes. They're not constants. So people, I see that they think that static variables are constants, but they're not constants. By default, they're not constants. Yes. So if you want to make it constant, then you need to declare it as final. Declare it as final. Now you see this variable, it becomes final now. Yes. Okay. So what if it is final? That means it's a constant variable now. I can say that the value of that variable will not change from, sorry, we cannot be changed. The value of that variable cannot be changed. Yes. It's fixed. You can try that. You see, once you declare it as final, now you can try reassigning the value for that variable. Let's say I'll try to do this 5, let's say. So it won't take it. So what's the error? So it says the final field savings account dot interest rate cannot be assigned. Okay, it's an error. So this is about two different types of variables which you see in a class, static as well as non-static variables. Now let's move on. So far we are representing the properties of an object, right? So we were representing the properties of a savings account object. So these are the properties which we saw, which are describing that savings account object. Yes. Okay. Now we'll talk about behaviors. Behaviors are withdraw, deposit, transfer of funds, let's say. These are the behaviors. Yes. So now how do we represent the behaviors? Behaviors means the actions which are performed by an object or on an object, I can say. Okay. Yes. So basically, yes, the behaviors of an object are represented as methods in Java. They're represented as methods in Java. Yes. Fine. So let's try to represent this behaviors. Like we got withdraw. Let's see. Now we'll try to represent that withdraw behavior here. A withdraw action, I can say. So we need to define a method for that. See public void, I'm defining a method in that savings account class. Okay. So Now, when we talk about withdrawal, a bank has got certain rules, right, for the withdrawal. Yes. So, what are the rules which we need to follow here for the withdrawal of amount? Yes. So, it depends on the bank. First of all, let's say, as of now, you'll find that for the savings accounts, you have a rule. What is it? Always there should be, I mean, a sufficient balance in the account. So the withdrawal amount um, cannot be more than that balance amount in the account. Withdrawal amount cannot be more than the balance amount here. That is not possible. So we have to implement that rule now. So you see that withdrawal amount, how much the user want to withdraw, it is passed as an input. This is a parameter here, okay? It's passed as an input here. So the parameter represents an input. The parameter, this is a parameter here. It represents the input, what value the method takes. Yes. So you have to check it. So if withdrawal amount is greater than the balance, or if it is less than the balance, I'm sorry, less than or equal to balance, the withdrawal amount should be less than or equal to balance. If so, we'll allow the user to withdraw that amount. So the application will deduct that withdrawal amount from the balance. Else, we'll display a message. I would like to display error message. That means in the red color. So I'll use system.err.println here in this case. Okay, use system.err means error. So it is actually an error. Yes. Okay. It represents errors. So I'll print a message. What is it? You got. Oh, sorry. You have insufficient funds. Let's say. Okay. So this is the functionality which I've written here. What is the problem? Okay. Now this code which we have written here. This is actually, I can say that it is business logic. I can say it is business logic. So what does that means? Business logic means, the code which implements the business rules. Now you see this code which you got here, we're implementing the business rules, right? So that's the reason why this code, I can say, it's business logic. So what are business rules? You see, as per the business rules of the bank, the user of the savings account is not allowed to withdraw more than what they got in that balance. Right? Yes. This is a requirement. Okay. So is it clear for everyone what we did now here? In this is a method. Now let's see how can we make use of this method. Okay. First, suppose I got two savings account objects. Okay. So now I want that withdraw method which we have defined. I want that withdraw method to perform withdraw action withdraw action on the first account object. Okay. I want the withdraw method to perform withdraw action on the first account object here. Okay. Yes. So how do we do that? Use that first account object reference to call the withdraw method. Yes. And pass the withdrawal amount. That's it. See, we are calling the method now. So I'm calling this withdraw method using the first account object reference here, right? Now, which indicates that here you want the withdraw method to operate on that object whose reference we're using to call the method. Yes. So now after calling that withdraw method on that object, we'll read the balance. Okay. Let's see. So withdraw method now should withdraw that amount 2000 from that account, from the first savings account object. Yes, so it prints 3000. Okay. So there are a few things which you need to understand here. You know what? When this method is called, you see, this is a method call. So this is not a method here. What is it? This is a method call or method invocation, I can say. So what happens when a method is invoked? when the method is invoked, you will find that the instructions which we have defined in this method. So that method, you see where is the method defined? Here it is. The instructions which you got in this method will execute. That is how it works. Yes. Yes. Now, you know, in the method, I'm using this here. In this method, we'll be using this. What is this here? Uh, Harshita, you got any questions?
Sorry, no.
It
Uh, okay, no problem. So this, what exactly it does here?
it represents the currently executing object.
Okay, current executing object. Okay,
Like this, the previous function call the account is the currently executing object, right? So this is used for that account.
okay. Yeah, just a second, please. Yeah, I'm sorry. So this here, okay. You know, in the previous class also we have discussed about this, right? This means it's current object reference. Yes, as you said, right? So in case of constructor, you know what happens when we have discussed about this in case of constructor, right? So what is this here? This means, so this refers to the object which has to be initialized by the constructor. This refers to the object which has to be initialized by the constructor. Okay, so I can say that in other words, the newly created object reference is implicitly, which has to be, I'm sorry, is implicitly passed on to the constructor, and it is stored, it is passed on to the constructor which has to be initialized by the constructor. Newly created object reference is implicitly passed on to the constructor, and sorry, which has to be initialized by the constructor, I can say, in other words. So now the thing is here, that reference where it is stored, yes, where is that reference stored? In this variable. Okay, yes. So the reference, object reference, which is passed implicitly is stored in this variable. Basically, it's a keyword. Okay, yes. This refers to the object which has to be initialized by the constructor. So the newly created object reference is implicitly passed on to the constructor, which has to be initialized by the constructor. Okay, yes. That always that object reference is passed on, and the object reference which is implicitly passed on to the constructor is stored in this variable. It is stored in this variable here. Okay, yes, or keyword I can say. This is what this refers to in case of constructor. Okay, please make a note of it.
I
Okay,
feel like using this dot balance might be a little confusing if you have to constantly use it. Wouldn't it just be easier to use like a variable like new balance?
you see, if that is the case, I don't talk about this variable so much. Even I don't like wasting the time. So that is not the case here. So, and generally we don't do that. So it is always better from years. Java is very matured. Even people who are developing Java applications are also very matured. Even I am also very matured. Since last 7 8 years I'm taking Java classes. So the thing is here, the variable names, the parameter names. Uh, First of all, there are 2 points which you need to understand. What is it? Okay, if I say, okay, go get this, or if I give some task to some person, let's say I'll say, okay, um, you know, let's say, for example, just take a very simple example. Let's say there are three laptops on a desk, just there are three laptops on the desk, and you'll ask your office assistant, let's say, or there is your friend or someone. So please mute your mic. Hi, Ritvik. Can you hear me?
Yeah, I can hear you.
Okay. Okay. So I'll your reference, Ritvik.
I'm sorry?
Your reference is it Sunil?
Yeah, Sunil.
Okay, fine. So Ritvik, this ongoing class. Just make sure that you mute your mic. I'll talk to you after the class. Just listen to the class, okay?
Okay, that's
Just
fine.
listen to the
Yeah.
class. I'll talk to you after the class. Yeah, and make sure that
Okay.
your mic is also muted. So if you got any questions, you can unmute and talk to me. Okay?
Okay.
Yeah. Uh, Make sure that you find that mic option. Mic symbol will be there. You can click on it. Your mic will be muted. Because otherwise, what happens is there will be some background noise. Echo will be there. Did you find mic option? Okay. Meanwhile, I'll mute you. So make sure that you check that mic where it is. You can see that mic symbol. Green color circle will be there where you'll find that mic symbol. Yeah, I'll mute you meanwhile. Yeah, okay, fine. So yes, you see, just imagine there are three laptops on the desk. Okay, so you're just sitting far away from that, and there is a person, a guy, just sitting next to that desk where you got three laptops, and you'll ask that guy to just switch on the laptop. You say, okay, switch on the laptop. Now that guy has to switch on which laptop? Yes, you got three laptops over there. If you simply say, okay, just switch on the laptop, okay, or start the laptop, what does it means? It's very vague, right? It looks ugly. So you should be more specific. Otherwise, the other person also won't understand what what exactly or which laptop you want to start exactly. Yes. So let's say, okay, the laptop which is blue color, a black color, or whatever it is, a red color. Yes, or it is better to point out, right? Here also, yes, constructor has got a job. What is it? It has to initialize an object. There can be many objects in the memory, so it has to initialize which object. There should be some reference to that object, right? So the main idea, was to make sure that always the constructor gets that object reference. Okay, the constructor always has that reference to that object which it has to initialize, and that is why always that is the reason why always that reference object reference is implicitly, that means without our intervention. Okay, we don't need to say to Java, or we don't need to ask Java to provide that object reference. Implicitly, whenever it creates an object, you see it will call it will pass that object reference. For suppose here you see this constructor is called twice. This constructor is called twice, right? We are creating two objects, and you will find that the call to this constructor, yes, it is in both the object creation statements. So you see, for the first time, when the first object is created as part of this object creation statement, you got a call to the constructor, and you see when that constructor is invoked, implicitly that object reference is passed. So now the constructor has got the reference to that object which it has to initialize. Yes, that's very important. Yes, right. So it should have, it's always better to have the reference. So the same is the case for the second object. Again, when the constructor is called for the second time, again the object reference is passed on. So, you know, now this time the constructor has to initialize which object? The second object, because the constructor is called as part of the second object creation statement. So this time this variable, it holds a reference to the second object. That is one thing which you need to understand. Hope everyone got it, right? So uh, you see, we got a good approach which you're following here. So the constructor is not blank, or it is not blind. It always knows what or which object. It always has a reference to the object which it has to initialize, right? Yes. So is this point clear for you people, all of you? Why this or what this is doing over there in the constructor? Okay. There is another point I'll let you know, but as of now, this. So, this variable, it is used to pass that object reference. Yes, this variable is used to pass the object reference here. That's it. Okay. Yes. So it is that this variable holds that object reference. I'm sorry. It holds the object reference which the constructor has to initialize. Okay. Now, here in this example, if you keenly observe the parameter names which you got here, they're same as the instance variable names. The parameter names and instance variables names are same. If you want, I can change the parameter names here. I can do this. Let's say A, B, and C. Still it works, not a problem. Okay. A, B, and C. We can do this. So if I do this here, then in this case, I don't need to use this. But still, even if you don't add this, compiler will add this later on. During the compilation, definitely compiler will add this because, you know, this this statement is very vague. This statement is very vague. So why? Because you see, we are referring to a variable, account number variable, but it belongs to which object? It belongs to which object? It should belong to some object, right? So which object, where is that reference? It is in this variable. So this dot account number. Now this makes some sense. This makes some sense here. Okay, that is one thing. Even if you don't add it, even if we don't add it, the compiler will definitely add it during the compile time. Okay, it adds it. So that's an extra work for the constructor. Of course, the compiler, it has to do that. Yes. And now, okay, maybe you think that if I give that parameter names different, so then I can just avoid using this. I can just avoid this. Yes, you can avoid it because the parameter names are ABC. So now that value of that variable, you are trying to assign it to that appropriate variables here. But do you think ABC looks good or is more readable? Do you think this variable names are readable, and can you understand which value here it refers to which variable or which property? Each parameter here, it holds a value, right? That variables, they refer to which property values. Uh, can we easily make out? A, B, C, which you got here, which I'm using the names here, the variable names. Are they readable? Uh, can we make out easily, like, that A, it holds which variable value? Not really, right? So they're not much readable here. So you see, that's the reason why always we follow the standard. We give the parameter names, or the parameter names here, you'll find that we'll name them same as that instance variable names here. Yes, the parameter names and instance variable names will be same. So that now it really helps us to understand, okay, that parameter, it holds which property value and it has to be assigned to which instance variable. Now this is more readable. So, but there is a issue here in this case. What is the issue? The issue is that the parameter name and the instance variable name are same. The parameter names and instance variable names are same. Am I right? The parameter names and instance variable names are same. So when I say account number in the method, in this constructor, am I referring to the parameter or instance variable? If I say account number, am I referring to the parameter or instance variable? You see, if it is plain account number this way, then you're referring to parameter, a local variable, I can say. It's just a local variable, a parameter. Just referring to that local variable. When you say this, that means it refers to that instance variable, the variable which is in that object. And this, it holds that object's reference, right? Now you're referring to the variable which is in that object. This dot account number means. Whereas only simply plain account number means in this method, it refers to the parameter. That's it. So is it clear for you people? Okay. So now You see, as I told you, it's always better to practice this, follow this approach because it helps us easily, right? To understand, yes, to understand that, okay, each variable, it, it, it maps or it refers to that particular property. Yes, each parameter here refers to that property. That's it. So more readable, that's it. And that is how, the approach which we follow here. Yes. Using this, it's not at all redundant. Even if you don't add it, definitely the compiler will add it. Okay. Yes, internally definitely adds it. Because just mere account number has got no meaning. So account number means it's a instance variable, right? It refers to which object. That is important. A reference of that object is very important. It has to be provided. Yes. Fine. So next, you see, when it comes to the constructor, you will find that, sorry, method, I'm sorry, not constructor. This keyword is also used in the method, but what exactly it is doing here? Again, I can say that the same reason. We got the same reason here as well. So can someone explain me why this again in the method? I can say it is the same reason. Yes. Why this here? So again, you see when this method, withdraw method is invoked. Now what is the responsibility of this withdraw method? What do you people think? What is the responsibility of the withdraw method? What it is supposed to do? So yes, it performs the withdraw action, I can say. That means not just it removes it, but it also checks that condition, right? Like that withdrawal functionality. Okay, that withdraw action will be performed on that object. Yes. So now the withdraw method, it is supposed to perform this withdraw action on which method? The withdraw method is supposed to perform withdraw action on which method here? You know, again to this withdraw method, again to this withdraw method, that object reference is passed. Okay, the object on which this withdraw method is supposed to perform the withdraw action, that particular object reference is passed on. Okay, yes. So this, it holds that object reference here. This holds that object reference. Okay, yes. So now this dot balance means, now this here in our example here, we're using first account object reference to call withdraw method, right? So this reference which we have used to call the withdraw method, that object reference is now in this variable. So in our case, it is first account object. Yes. So this refers to that first account object, I can say. Yes. Okay. So hope you people got it. So please make a note of it. So this in case of methods, especially it is called as in case of method, if you use this refers to the object whose reference was used to call the method. Yes. This refers to the object whose reference was used to call the method. Okay. Yes. Yeah. So did you people make a note of it? So this way now we can be more specific about the object on which you want that method to operate. Yes. It will be more specific. Yes. Okay. Now what if I want that withdraw method to perform the withdraw action on the second account object? So what to do? What if I want the withdraw method to perform the withdraw action on the second account object? So what to do? So use the second account object reference. That's right. So you can do that. Account 2 dot withdraw. Okay. Yes. And this time when the withdraw method is invoked, you see that this withdraw method will be called, right? So now in the withdraw method, now this refers to which object? For the second time the method is invoked, right? So when it executes, this refers to which object here in this case? It refers to the second account object here. Yes. Okay. So now you understood how to represent the behaviors of an object, right? The behaviors of an object are represented as methods, whereas the properties of an object are represented as variables here. Yes. So now similarly, you can also implement that deposit method. Let's try to do that. Deposit. So public, let's say I'll do this deposit. It should not be float. Let me make it int. Okay. So int deposit amount. So if deposit amount is greater than 0, it should be greater than 0, right? So it should not be negative. Then this dot balance equal to this dot balance plus deposit amount. Sometimes, if we don't check this condition, then if you pass a negative value as a deposit amount, then instead of, depositing, you'll end up withdrawing the amount from the account, right? Okay. So let's say invalid amount. Invalid deposit amount, let's say. That's it. Okay. So now you see this methods which we have defined here. There is something special about this methods. What is it? These methods are actually called as instance methods, or we call them as non-static methods. You know, I'm using this term instance a lot here, right? I said instance variables, now I'm saying instance methods. So what exactly instance means here? What do you people think? What exactly instance means here? It refers to an object. I can say that here instance or object means the same. So here I can say that instance or object means the same. They're both synonyms. So instance or object means the same. So from now on, if you hear this term instance or object, or instance means you have to think, you have to understand that I'm actually, I mean object here. If I say instance, I mean an object, that's it. I'm referring to an object here. Yes, fine. Okay. So earlier we saw non-static variables or instance variables. Why we are calling them as instance variables? Because you see, they will be part of an object. The memory for that instance variables will be always allocated as part of that object. Yes. But when we talk about, again, non-static methods or instance methods, again, they got something to do with the object. Basically, this methods, you see, I'm saying they're instance methods. That means the methods which operate on the object, you see, they got access to the object. We always use an object reference to call that methods, right? Yes, we have always, that method has got reference to that object always, and they operates on the objects here. So when I say operating, what does it means? What are they doing exactly here? They're trying to say in our example, they're trying to update that savings account balance, or they're reading the savings account balance. You see, they need not always update, right? For suppose if that withdrawal amount is greater than the balance amount, then in that case the method is not going to update the balance, right? It won't modify it. Yes, but still it is accessing that object, it reads that balance. Okay, so they got access to the objects, these methods, and they operate on that objects. They got access to that objects. You see, they modify the uh, fields or values which are stored in that fields. Okay, you see the data which is in that object, basically we call it as an object state. Generally, you'll hear this term also. Object state means the data which is in that object. Yes, fine. So in other words, I can say that the methods, they operate on the state of that object here. Yes, they can modify the state of an object. Okay, so that is the specialty about this methods. You see, they always will be used to call, how they are invoked. They are always invoked using an object reference, and always the object reference is applied to that methods here. Yes, fine. So you know what, we got another type of methods here called as static methods. Now we saw that non-static methods, they operate on the objects, right? What about static methods? Any idea? Anyone got any idea about static methods here? Okay, they operate within the class. Okay, so yeah, I can say that non-static variables basically, sorry, non-static methods or instance methods, you see, they operate on this non-static variables. Am I right? Can I say that they operate on the non-static variables? When I say operating on the object, means in the object what you got, non-static variables. So I can say that the the instance methods, they are operating on the non-static variables of an object. You see, balance, what is it? It's a non-static variable. So the withdraw that this non-static methods, always they'll have access to that non-static variables, and they'll be operating on that non-static variables, I can say. Okay, hope you people got it. Now the static methods, I can say that they operate on the static variables. Static methods, they operate on the static variables, I can say. Yes, you see, I can define a method this way. Now, you see, I have highlighted that code. What exactly that method is doing here? What is this method doing here? Sorry. Yes, can you people tell me what is this method doing? Get interest rate. So it won't show, but instead what it does is here it returns that value. It returns that value which is stored in that variable. Am I right? So simply it returns the value which is stored in that static variable. Simply it returns the value which is stored in that static variable. Fine. So to whom? To the calling method, I can say. It returns a value to the calling method. Yes. So I'll do this. The static methods are invoked using the class name itself. So we saw that non-static methods, we call them using um, object reference, right? But here we use class name to call static method. So when we call this method, you see we are calling the static method. So what it does, it returns a value stored in that static variable interest rate. Yeah. You see this is a static method. How I'm saying it's a static method? So we're using the class name here. What we did, basically, we are using the class name. Okay. Now, only this keyword static is the difference between static and non-static methods, or is there any other difference? Can you people tell me? Yes, is anyone familiar? Only that keyword is a difference, or is there any other difference? Um, no, I'm trying to relate. We'll try to relate this static methods with non-static methods. So, I mean, you see, if you see the non-static methods here, you got withdraw and deposit, both are non-static methods. So you won't find a static keyword used here in non-static methods, whereas in static methods we're using static keyword. And okay, you see, this is one difference, and the other difference which we saw that we can use a class name to call the static methods, but we can't use class name to call the non-static methods. Okay, so is this the only difference, or is there any other difference apart from this? Can you people tell me between this, between the static and non-static methods? Is there any other difference? It can use in, okay, I got one more answer. Let me see. Uh, okay, it can use in common. Fine. So I'll tell you people, you know, for the non-static methods, as I told you people, the object reference is implicitly passed, right? For the non-static methods always, the object reference is implicitly passed and it is stored in this variable. This you will find that this variable, it is available for the non-static methods and it holds a reference of that object which was used to call this method. That current object reference is available for non-static methods. But can we use this here in static methods? Can say no. For static methods, you can't use this. For example, you can try doing this dot balance. You'll get an error. Cannot use this in static context, it says. Cannot use this in static context. Yes. So that means this is not available for static methods. So that means we cannot access non-static variables from a static method. We cannot access non-static variables from a static method. You got the point? We cannot access non-static variables from static methods. That is another difference. So this keyword or the current object reference is not available because the static methods are not invoked using object reference. For static variables, that object reference is not available. So we cannot access non-static variables from a static method. We cannot access non-static variables from a static method. So is it clear for you people? Can I have yes or no? Can I have yes or no? Okay, good. Thank you. Yes. So that means what we can what we can summarize here is that static methods are used to access static variables or to operate on static variables, and non-static methods are used to operate on non-static variables here. Yes. Now few people they ask this question also. They have a question. Okay, now you know that we cannot access non-static variables from a static method, right? The other way, vice versa, can we access static variables from a non-static method? Can we access static variables from a non-static method? Yes, you can access them. You know, you'll find that from a non-static method, you can access static variables. We don't need any object reference because they belong to the same class, right? The methods and the static variables, they both belong to the same class. So we don't need any object reference in this case. Yeah. We need only class name, right? So you can just do this. we can do this. So we can access static variables from, sorry, yeah, from non-static methods. We can access static variables from non-static methods here. Yes. And here, I'm expecting one question from you people. When I say we can access static variables from non-static method, I'm expecting one question in this case. Yes. Is anyone having any questions? How about non-static variables with static? We can't do that. They already have shown you people. So from from a non-static from a static method, we cannot access non-static variables. That we already saw. First, we saw that the first thing which we saw was that we cannot access non-static variables from static methods. But I'm expecting one more question. Okay, if we can access both static and non-static methods, sorry, if we can access both static and non-static variables from the non-static methods, right? We can access both static and non-static variables from the non-static methods. Then what is the use of static methods here? Do we need static methods if we can use non-static methods to access both static and non-static variables? Then why do we need static methods at all? Is there any need for that? Okay, don't worry about the answer. At least you people understood the question here. Okay, you know, yes, we can use non-static methods to access both static and non-static variables, but there is one obligation here when we talk about non-static methods. You see, in order to call that non-static method, always we have to create an object. We need an object reference. To call that non-static method, we need an object reference. So it is better to use non-static methods for non-static variables only. And you see, always we need object reference here to call that method. Whereas static method, you see, if we use a static method, we don't need any object reference to call a static method, right? We can just simply use the class name and call that method. So, so we can use static methods here without creating object reference. We can call them just by using the class name. Otherwise, if you only use non-static methods, then you need an object reference always, even to access static variables. Yes, there is no need of object reference to call static methods or access static variables, right? Yes, so we can avoid that object creation. So if you want to only work with that static methods, static variables, you can do that, right? So hope you people got it. Yes,
Yes, Mahesh.
Okay, fine. So good, thank you. So now, hope most of you people might you may have that question of static main method. Why main method is declared as static? Maybe now you know void. Void. I'll also talk about it. Don't worry. So why this method is declared as static here? Because you see, uh, who calls this method? JVM. And JVM now it calls this method whenever we run this application. Whenever we execute this application, what happens? JVM will search for the main method and it calls that main method. You see, now the JVM, it need not create an object or it need not use an object reference to call this method because it's a static method. Now it is easy for the JVM to call this method because it is simply static. Yes. If it is not static, then the JVM has to instantiate this class in order to call that main method. Okay. That's the reason why you see this main method is made static so that JVM can simply call that method without using any object reference here. Okay. Yeah. Just a minute, please. Yeah, I'm sorry. Can you people hear me?
Yes, Mahesh.
Okay, sorry. So, so this is about your class and various members of the class here. Now we can broadly classify the members of the class into two categories, right? So members of the class, static members and non-static members. Static members means static variables and static methods, whereas non-static members means s- non-static variables, sorry, or we also call them as instance variables, right? Non-static or instance variables and non-static methods or instance methods. That's it. Okay. So this is about a class now which represents a group of similar objects now, savings account objects I can say. That savings account objects which we have created, you see, we are trying to simulate a real world object, right? Now we are able to represent the properties of that real world object Okay, so we have represented the properties, which are two different types again. Properties whose value will change from object to object, like account number, balance, pin will change from object to object. So they are that properties are represented as instance variables, whereas the properties whose values will not change from object to object will be same for all the objects. So that properties are represented as static variables, right? And the constructors are used to basically initialize the object. That means assign some initial values to the instance variables which are part of the object. Next, we saw methods which represent the behaviors of an object, right? Or the actions, behaviors, I can say. That's it. So I'll stop it here today, okay? And we'll meet tomorrow at same time, and we'll continue our discussion, okay? I may take a 3-hour session tomorrow, 3 end of us, okay? This weekend I'll make it, yeah. So yes, that is what I'm going to talk about, yeah. Now you see, we are able to uh, shape this class completely. Now we got a complete overview of a class. Now you know the members of a class. Yes, I can give it, okay? Though I know you people are curious, but yesterday, you see, if you take yesterday's topics, you know, it's not that good idea to give an assignment on based on that topics. So today, what you can do is, I want you people to define a class for a circle object. Define a class for the circle object, and make sure that you identify the properties and behaviors and represent the properties and behaviors of the circle object in the class. And not only that, also implement all the concepts which you have discussed, like constructors, parameterize constructor to initialize that object, okay? Represent the properties of the circle object as variables. Try to identify both static and non-static variables, and methods, okay? That circle object, what operations we perform on the circle. So try to take this task, okay? Try to complete it. So this is your task. So you have to define a class for the circle object, okay? uh, Try to identify the properties, behaviors. Now when we talk about properties, we saw that the properties values can change or may not change. Yeah, try to identify both the properties, okay? And behaviors, the methods, what actions we perform in the circle. That's it. Yes, a circle. uh, in Max, you might have come across this circle, right? A circle object. A circle has got radius, diameter, okay? Area, we calculate area for the circle. Yes, got it. Okay, so any other questions?
No, Mahesh.
Okay, fine. Can we start a bit early tomorrow? Maybe. Okay, others are leaving. Next week we'll try Deepak. Okay, even I have to check once. Yeah. Okay, sure. Okay, then thank you all. Bye bye. Yes.